Justin Buck, and I'm going to be presenting the ENVRI Plus use case on sensor registries. I'm going to show where the work comes from, through to how we've applied standards and worked in marine domain, and then we're going to go through and show some of the potential and how it potentially links into future projects as part of this. So this is work that started at the beginning of ENVRI Plus, looking at this page here called the Ethernet Yellow Pages. And this is a database of sensors, effectively. So effectively you've got a connectivity sensor here, for example. You've got hardware components, deep sea components. And the question was originally raised by the original organizer as to how can you share this metadata in a machine readable, friendly way, so it can be used for the provenance trace of the data. And how can you link together different repositories? So for example, I work at the British Oceanographic Data Centre. We're building a sensor repository for gliders. This Ethernet Yellow Pages is used for the mooring work, which is linked to EMSO. Pangaea built a registry, Arvia built a registry. So there are multiple groups with multiple registries, and it's how can you link these together and how do these standards work together? So it comes from there. And this is all built on a set of standards and developments which came in around 2002, 2003, and a concept called Sensor Web Enablement. The principle of sensor enablement is to effectively connect and standardize the data and metadata from sensors all the way from the observation through to delivery to users. The concepts go back about a decade, and it's only in the last 3 or 4 years that within the marine domain we've started to create a marine implementation of those standards, so you can actually use them in a machine readable way. The standards in their kind of prescribed form are syntactic, so you've got effective XML documents, and using those documents we very early on actually started to implement these and try these standards. We found that you could have different names for things, so you could have manufacturers spelled different ways, you could have typos, you could have things like salinity, which is the property you're measuring, spelled in different ways or represented different ways. We found it very hard to implement the standards with that kind of flexibility, because in the data management world we come from a world where people use free text and the human eye recognizes the words very quickly, but a machine wouldn't recognize the subtle differences that people were using to describe their data. So we took a bunch of standards which came from the Sensor Web Enablement Initiative. So we took one called SensorML, which is an XML document, which I'll show you an example later, which will describe sensor metadata. We took something called Observations and Measurements, which is an XML document to describe the data. And we took another one called the Sense Observation Service, which is an API onto that data. And we'll show you examples of those as we go on later. So as I described already, the first issue we had was how do we apply these things in the marine domain? And we found very quickly that syntactically things were working quite well, but semantically we find it very difficult to use the standards because people are calling things different names. So we started a community called the Marine SWE Profile, and this is their GitHub page. And effectively what we've done here is we've documented as a community effective marine implementation of those standards which are described on the previous screen. So if I open this new tab, so these pages describe the group, and then effectively what we've got here is how you put the document together. The key things we introduced are vocabularies. So we started to use vocabs to describe terms. I'm going to show you some examples of real vocabs soon. Here's the vocab. So this is a vocab called W05. It's hosted by us at British Oceanographic Data Centre, and effectively it's a vocabulary of characteristics of SensorML. So within that document that we're using to describe the data, and I'll show you an example soon, we're actually using a vocabulary to describe the term. So data storage is a term which you'd want to something you'd want to know about a sensor. and we've actually got a controlled vocabulary to describe that term. So it doesn't matter how you spell it, how you type it, so long as you put the URI in, it takes you to a unique definition for that term, which is the most important thing. And these are our vocabs. So I'll show you a document soon, but I just want to show the vocabs first. If I go sorry, here we go. So the types of vocabs we're using, one of my favorites here is L22. Search. So L22 is a vocabulary of different sensor types. So this gives you a unique and ambiguous way of describing a sensor. So for example, this is a thermistor, and this could cover multiple domains. So in L22, we've got atmospheric sensors and we've got marine sensors because we work in the oceanographic domain, we need atmospheric data as well. But the vocabs don't necessarily need to be hosted by us. It's any vocab and any vocab that follows good governance around the world can be used to identify these terms, the key things that we use in the vocab to do it. The other vocabs we've created, if I go back, scroll down here, and we've got something called LO6, which is platforms. So whether you've got gliders, platforms, aeroplanes, we've actually got a vocabulary of platforms. So you can unambiguously describe your observation platform. Then at the bottom here, we've got the key vocabs, which are these W vocabs. So all these W vocabs, these are the ones which are used to describe the elements within a document. Are you looking at the manufacturer? Are you looking at sensor characteristics? Are you looking at sensor properties? I'll show you one of those again before I move on. So this one effectively is the W02. Which includes things like sampling rate of your sensor. So this base gives us pieces. So effectively what we have is the OGC standards. And we have the vocabularies so we have the standard to format the information, and we now got the vocabularies to describe the information. So when you link these two together, you get the Marine SWE profile. And that's so effectively the fundamental tenet of Marine SWE profile is what we've done is we've taken standards produced by OGC, we applied vocabularies to them to create effectively unambiguous documents to describe sensor and data provenance, which means this work ties quite nicely with other MV+ provenance work, and you can also link it to the effectively the work package 8 design principles catalogue as well. And we have examples. So this is an example which comes from Italy. It's not fully. So it's a wind sensor, and this is the unique identifier, and it's an OGS sensor. And if I scroll down, you have things like you have the outputs wind speed, so it gives you no. And then if you scroll down here, you can see it points directly to the VODC vocab server, which I just showed you. So effectively, you've got the metadata of that sensor. You know what type of sensor it is, and you know what it's observing in a unique way. Another example I've got, so this is in the XML. I also have an example in JSON. So this is a JSON representation of a similar information, but from a project I work on and be able to see. And this is the description of a glider deployment, so an ocean glider deployment. It's from the UltraEco project. They have live gliders in the water at the moment. And this is a real. This is the JSON representation. I originally used JSON. It's a bit easier to see on screen. It's a bit easier for a human eye. It's a bit easier to use rather than reading the XML. But you can see it's a Slocum glider. It's got this unique ID. It's made by this company. It's got a WMO instrument type, so we can tie it to the World Met Organization. And scroll down. You've got the ICOS codes, so you can uniquely identify that platform. And then if you keep going down, you can see that we've got effectively the information. So in the source files, this is this information. This is the name of the variable that comes out, and then we've mapped that to some units, which is this mapping here on the vocab server again, and we've mapped it to a P01 term which describes it. So P01 is the name, so that's the vocabulary name for the wind speed that's in the x direction. If you keep going, you've got latitude, longitude. So effectively, this document fully describes that source data, fully describes that platform. And what we've done with this document, in addition to exposing it to the web so people can actually see where the data's come from, is we've used this to automate data flows. So we've used this to effectively fully automate the glider data flow in our organization. So that's the metadata nicely described. I mentioned at the beginning that you got a sense observation service. So what you can do once you've got that metadata and nicely organized, you've got it in the right formats, is you can then expose that to the web. And this is a 52 North client. So 52 North is a company based in Germany, and they developed the 52 North software. 52 North software has a history which goes back about 10 years, and it's been through a few iterations, a few versions. And 52 North is now the custodian and the company which is developing the software. And this is freely available open source software, so anyone can install it. We've got examples in the atmospheric domain and the marine domain. And if I just pull up an example query, get capabilities. You do a quick get capabilities query, and that will tell me the capabilities, the sensors, all the sensors in the system. And because this is an API, you can build these queries, and then you can effectively host them on your own site. There's a standardized interface into those queries. And if you scroll down, let's find some. You can see here what we're doing is we're pointing at these elements here, and these are the instances of those sensors. So if I go back a tab or two, this effectively is a sensor instance. So these elements here link directly to here. So you can actually use the sensor observation service interface as a standardized API to get to the data. Why is that important? That is important because this is a service which was built as part of the Nexus project for Helgoland by 52 North. And they've built effectively a nice web interface on top of these services. So you've got standardized metadata, you've got standardized data, which I haven't talked about much because it's not really part of the use case. Use case is about the metadata. And you've got your sensor observation service client. And then you've got this, what they've done is they've built a nice web interface on top of this. This is data of Galway. And I can click on there and you can see what's been observed. So from a human interface, you can look at and read the data very easily. And then I want to show you a plot, hopefully. There you go. And what you can do is you can effectively plot that data live from a web interface. And this is a standardized interface, so it means that anyone can build a service using those standards. So it reduces the amount of work in building web portals and web API, web systems to display that data. And that's kind of the point of this. The point is effectively we've got the same organizations. We had the Oceans Tomorrow projects, which are all worked on this. There's 4 projects: Common Sense, Nexus, Sense Ocean, and there's a 4th one. And they've got projects like Bridges, who are working on autonomous underwater vehicles. And they've all, in the European Union, they've all been developing these standards and applying these standards. And they've all got the same endpoint, and everybody can get their data on the same map without needing to harmonize their standards. And that's kind of the point in all of this work. And I've got one last little piece to show before I show you kind of where we're going next. I showed you a little about the SensorML. It's quite hard to edit from a human point of view. So 52 North have produced a nice editor, which you can use as a human being to actually edit and work on that SensorML. So that's this document here, which isn't very friendly from a human being to use. So 52 North have produced a nice client called Smiley, which allows you to work and add elements to last little bit. So what I've showed you is effective standardization of data. That ties very neatly into the design principles in work package 8 and also the provenance work. It fits very neatly with the research infrastructures, because effectively EuroGOOS, as part of the EMONIT project, they've done test exposure of these standards to the web for EuroGOOS, for EMSO, and ocean sites. But this kind of feeds quite neatly into the future. So the EMBI Fair project's just been funded. And as part of the, for EMBI Fair stands for the FAIRs and the FAIR principles, where data have to be findable, accessible, interoperable, and reusable. The work I've just shown you effectively makes the if I highlight this line here, the metadata interoperable because it's readable by machine, and we use vocabularies. So the work we've done and the work we show here is actually key to our future goals to actually achieve the FAIR principles as an organisation. And that's what I have to show in this demo. Thank you for your time.